Hello, my people. In this video, I'm going to quickly go over how to calculate power, or rather, given a power that you want to achieve in a study, how to calculate the sample size that you would need. Just to quickly go over the definition of power, the definition of power is the probability of rejecting your null hypothesis, which is saying that there, in most cases, that there's no differences. Let's say you're comparing to drug treatment, the null would be that there's no difference in the response that you're looking for between the treatment groups. So the power is the ability is the probability of rejecting the null and saying that the experimental group that you have is actually different. Sorry, so the power is the probability that you are saying that the experimental group is different than the null group or the control group, given that it actually is different. So it's like the probability of finding the true effect. When you're calculating power or sample size, when you in order to achieve a certain power, you need a certain sample size given the amount of differences in effects you want to see. So, like, let's say you're trying to do a study where you want to find out where you think you're going to find a let's say you're doing like testing differences in blood pressure medication, and you believe that this medication or this regimen will have a 20 unit difference in blood pressure um, in the experimental group than the control group. So, given that difference and the power that you want, let's say you want 90% power, it's going to require a certain amount of observations total. Uh, the way that we can do this in R is just by using the power function, which you can get from the power package, which I need to download. So we'll do install packages, and we'll do power. I think I have to put this in parentheses to run it. So it's just running right now. Okay, download it. So now we have that. So now I'll just go through a quick example of using the power function. So um, the power library has different functions based on the type of test, the test you're ultimately going to be doing to compare the effectiveness of a treatment, or to compare different groups in a study. So let's say we use an example where we're testing the mean blood pressure change in a treatment group with a new regimen versus the current regimen. So when you compare averages between groups, you're going to use a t-test. So let's use the power dot t-test t-test, and then I actually need to call. That's why. Let's do library power. Okay, so now it should show up. So power dot t test. And then, so the first thing, since we're using this in our case to estimate the total sample size we need in order to get our effect size, we're going to leave, usually we write the sample size, we'll leave it blank. And then we need to assign the value D. So D is going to be it's going to be the ratio of your the difference that you're trying to see. So that, like, let's say we were saying we're trying to see we believe we're going to try to see a 20 millimeters of mercury difference between the average blood pressure drop in the treatment group versus the control group. So let's just, before I write that, I actually have to make these objects. So let's say delta, which we're going to say is the difference. Let's say delta is equal to 20, which says 20 millimeters of mercury. That's going to be difference. And then we're going to do sigma, which is going to be the variance. So whenever you do these tests and you run these studies, you need to put in variance because there's always going to be a difference in the types of populations you're working with, and there's going to be a variation in the blood pressure change amongst participants. So you need to include variance or standard deviation into our study. So let's say there is a variance of 60 in our study. So D is going to be, which is going to be the effect size, is going to be the ratio of delta to sigma. So now I would have that. We'll do the power test. So we have D is equal to D. We have that object. Now we have to say the significance, level of significance we want. Usually it's going to be 0.05. That's like whenever you're testing estimates in a study, you're gonna when you're finding the p-value, you want it to be less than 0.05. So that's going to be that number, 0.05. And you need to do the power, which, let's say in our case, is 90. But it's going to be different depending on what study you're doing. And then, like we said before, we're doing 2 samples, and it's going to be a experimental group and a control group. So okay, so let's run this. Oh, I did should be 0.9. Copy and paste. Oh my god. This is fun. All right. 4th time's the charm. All right, no error, and it's between 0 and 1. There we go. Okay, so here we go. We would need 190 people total to do this test. And oh, never mind, sorry. This already gives us, that's cool. It says N is the number in each group. So we would need 190 individuals in each group, the experimental and the control group, to find a 20 millimeter mercury difference in blood pressure between these 2 groups. So that's, yeah, that is a quick way to have our calculate the sample size for you. It's pretty simple. You just need to know do research on finding the variance, because this level these two levels are really based on research, background research into the studies that you're on the studies that have previously looked at the issue that you currently care about. So that's really it for this video. And hopefully in the next one or the next coming ones, I'll be able to fill in any of the gaps in code that I missed throughout the previous videos. That's it for this one. So I hope you guys have a nice day.